At 04:20 in the morning, a Ukrainian reconnaissance aircraft was already in position above northwestern Crimea. The Leleka 100 had been circling at altitude for 11 minutes, its sensors feeding live imagery back to a security service of Ukraine command room, where officers were working through the final details of an operation they had been preparing for weeks. The mission was specific, and the logic behind it was straightforward. After Ukrainian strikes had already damaged the Chonhar crossing in the northeast and multiple secondary bridges across Kherson Oblast, one land route into the peninsula remained functional at anything close to full capacity: the Armyansk Bridge, the last connection through which Russia could move armored vehicles, fuel tankers, and ammunition convoys from the mainland into Crimea on a reliable schedule. Sever it, and the encirclement that Ukraine had been building bridge by bridge over the preceding 2 weeks would close. Then something appeared on the Leleka 100's feed that had not been in the mission briefing. From the north, a Russian military convoy was moving toward the bridge. The vehicles were carrying weapons, ammunition, and logistics equipment. Armored escorts were positioned at the rear of the column. At its current speed of approximately 16 kilometers per hour, the convoy would reach the bridge in minutes. If it crossed, Russian forces across the peninsula would receive a supply injection at exactly the moment Ukraine was tightening the pressure. Inside the command room, the officers had 30 seconds to make a decision: continue with the original mission and strike the bridge, or use the bridge as the killing ground and take the convoy with it. The order came: both. The problem was that everything required to execute that combined strike was already operating under threat. The Leleka 100, providing the real-time picture, was not invisible. Every transmission it made, every data packet sent from the aircraft to the ground control station, left an electromagnetic trace in the spectrum. Ukraine's operators understood this. So did the Russian electronic warfare and reconnaissance units that had been covering this sector specifically because Ukrainian drone operations against Crimean infrastructure had been intensifying for weeks. Russia had positioned a Yastreb AV counter-battery radar system in the operational area. The Yastreb AV was designed originally to track the flight paths of artillery shells and rockets back to their point of origin, so Russian batteries could return fire on the launch position. In Crimea, it had been repurposed. The system's operators understood that every UAV control link produced a detectable signal. They did not need to shoot down the aircraft overhead. They needed to triangulate the ground position of the crew controlling it, pass the coordinates to artillery, and let the guns do the rest. Counter-reconnaissance by fire. No visual confirmation required. Detect the signal. Calculate the bearing. Correlate multiple bearings into a position fix. Fire. The Ukrainian control crew had to maintain awareness of the convoy and the bridge while simultaneously avoiding giving the Yastreb AV the sustained transmission time it needed to build a reliable position fix. Their solution was frequency hopping across 148 separate channels in a randomized sequence that made signal tracking exponentially more difficult. Data transmissions were compressed to bursts of 0.3 of a second, just long enough to maintain aircraft control and receive a single frame of imagery, short enough to prevent the electronic reconnaissance stations from completing an analysis before the frequency shifted again. It was the operational equivalent of speaking in fragments, pausing, changing languages, and starting again, maintaining just enough coherence to function, while denying the listener the sustained sample they needed to locate the source. Then the Leleka 100 sensors detected an Orlan 30 reconnaissance aircraft climbing from the south. The Orlan 30 was not a strike platform. Its mission was observation, to locate the Ukrainian control crew that the Yastreb AV had been triangulating. Russia had escalated from detecting signal traces to actively hunting the people producing them. The situation had reversed. The aircraft watching the convoy was now being watched itself, and the strike team waiting 4 miles from the target still needed the final targeting package before they could move. Subscribe now if you want this level of operational detail on every major Ukrainian strike operation. This channel covers how these missions actually work, not just whether they succeeded. The Ukrainian crew made one final transmission, a data packet on the 444 MHz band, duration 0.5 of a second, contents, GPS coordinates of the convoy's current position, speed, direction of movement, wind conditions at bridge level, and the optimal intercept angle for a drone approaching from the southwest. Then the crew went electromagnetically silent. 0.5 of a second. Too brief for the Yastreb AV to complete a bearing analysis. Too short for the electronic reconnaissance stations to identify the signal as a command transmission rather than ambient spectrum noise. The Orlan 30 had nothing to follow. The control crew had disappeared from the electromagnetic environment before the Russian system could respond to the fact that they had been there. The strike team received everything. The FPV drone was already powered and oriented. The target was 4 miles out. At operating speed, that was under 5 minutes of flight time. Straightforward in a clean electromagnetic environment, something considerably more complicated in the one that existed between the launch point and the Armyansk bridge. The first mile went without difficulty. The drone flew low, using the terrain features that broken infrastructure and agricultural field margins provide along occupied roads, tree lines, earthen embankments, the silhouette of damaged structures. The video feed was stable. The convoy's position matched the coordinates from the Leleka 100 package. The approach geometry was correct. At 1.5 miles from the target, the screen began to break apart. The R-330 Zytel electronic warfare system had activated. After weeks of Ukrainian strikes against Crimean bridge crossings, Russian commanders had repositioned Zytel units to cover the remaining functional crossings specifically. The Zytel's function is electronic area denial, flooding the frequency spectrum across a 10-mile radius with interference that degrades navigation signals, communication links, and the control frequencies that FPV drones depend on to maintain the connection between the operator and aircraft. The video feed dropped from 60 frames per second to 15. The image became a stuttering sequence of partial frames where details dissolved into pixelated noise between updates. The convoy ahead, visible clearly at 1.5 miles, became a set of dark shapes moving through electronic weather on the operator's screen. The operator switched to a backup frequency. Part of the signal returned, weaker, with higher latency, but sufficient to maintain directional control. The drone continued toward the bridge. The Zytel was not the only defensive layer. Vehicle-mounted jamming stations had been positioned along the approach routes to the crossing, creating overlapping coverage zones that each attacked a different part of the frequency spectrum the FPV was using. The closer the drone flew toward the bridge, the more of those zones it entered simultaneously. The cumulative effect was progressive, each additional layer reducing the operator's visibility and control margin by another increment. The autonomous target lock mode on this FPV could take over guidance once it had a stable visual lock on a target. But stable visual lock required the target to be within 500 yards and visible with enough clarity for the pattern recognition algorithm to establish and hold acquisition. The drone was still over a mile from the bridge. It had to cross another mile of stacked jamming before the autonomous mode became relevant. The operator switched to dead reckoning. The Leleka 100 package contained the convoy's position at transmission time, its speed, its direction, and the elapsed time since the data was sent. Combined, those figures produced a calculated current position, not confirmed by live imagery, but derived from physics. If the convoy had maintained its speed and heading, it was here. The drone was at this position on this heading. The intercept geometry said the strike point was ahead and slightly left. The operator flew to the calculation. At 3/4 of a mile, one frame appeared clean through the interference. One frame, approximately 16 milliseconds of unobstructed imagery, showing the bridge ahead, and the convoy's lead vehicles positioned across it. The calculation had been accurate. The drone was on the right heading. The operator held course. Then a second contact appeared in the upper corner of the feed. A Russian Yoka interceptor drone was diving from approximately 15 meters altitude, angled at 45 degrees toward the Ukrainian FPV's projected flight path. The Yoka is a dedicated anti-drone platform, small, fast, carrying no payload other than the kinetic energy of its own airframe delivered against the target at maximum speed. It does not need to survive the engagement. It needs to reach the target. The physics of the intercept strongly favored the Yoka. It was higher, which converted to speed in a dive. It was lighter, carrying no warhead. Its thrust-to-weight ratio was better. and the Ukrainian FPV was already energy depleted from forcing its way through the jamming zones. Its battery down. Its maneuverability reduced by the weight of its explosive payload. The two aircraft were closing at a combined speed of nearly 300 kilometers per hour. At that closure rate, 1,000 feet of separation disappears in under 2 seconds. The Ukrainian operator banked hard right. The FPV rolled to 60 degrees. The left motors cutting to minimum, while the right motors pushed to maximum. The horizon on the feed tilted violently. The bridge disappeared from the frame entirely. The Leleka passed through the space the FPV had occupied half a second earlier. The evasion worked. The battery did not recover what it cost. The Leleka pulled up, gained altitude, and began repositioning for a second pass. Higher, faster dive, better angle. The same physics advantage, applied again with the operator having learned from the first attempt. The Ukrainian FPV could not climb to match it. Too heavy, too low on charge, still inside the jamming envelope. Every evasive maneuver was spending energy the drone needed to reach the target. The Russian interceptor climbed to 25 meters and held there, repositioning for a vertical attack where gravity would give it terminal velocity that the electric motors alone could not produce. The Ukrainian operator cut the throttle. The FPV dropped from 15 meters to 3 meters in under 2 seconds. The ground filled the camera feed at an angle that looked like impact. Broken concrete and dry field margins rushed upward at the lens. The Leleka's dive tore through the airspace the Ukrainian drone had been occupying. The interceptor overshot into empty air below where the FPV had been, needing several seconds to bleed its dive speed before it could reacquire. The operator brought the throttle back up in controlled increments. Too fast and the torque differential between motors would roll the aircraft. Too slow and the ground contact was real. 15%, 20, 30. The motors caught. The aircraft stabilized at 4 meters altitude, its battery at the critical threshold, its nose pointed toward the Armyansk bridge. The dogfight had lasted 20 seconds. It had consumed 35% of the remaining usable battery reserve. The convoy's lead vehicle was 3/4 of the way across the bridge. The BTR-80A at the rear of the convoy had been tracking the aerial engagement by sound. The 30mm 2A-72 autocannon elevated. The coaxial PKT machine gun aligned with it. The crew did not have a confirmed visual on the FPV. At 4 meters altitude and high speed, a small carbon fiber airframe against a gray morning sky is difficult to acquire optically. But they knew the general direction, and at close range, area suppression fire creates a density of steel through which a small drone is unlikely to pass undamaged. The 30mm cannon opened fire. The rounds passed ahead of the FPV's current position. The operator adjusted heading by 5 degrees, small enough to maintain the approach geometry, large enough to shift the drone's predicted position outside the cannon's current aim point. The PKT joined in, sweeping in longer bursts that created a horizontal plane of fire across the approach path. One burst passed within meters of the airframe. The flight controller compensated through differential motor output. The battery dropped another threshold. The target distance counter read 200 feet. The cannon tried to depress its barrel to track the FPV's decreasing altitude. The physical geometry of the BTR-80A's mounting limited the depression angle. As the FPV pressed lower, down to 1 meter above the bridge deck, flying along the length of the convoy rather than across it, the vehicle's own structural profile began masking the cannon's engagement angle. The warped guardrails, the steel bridge beams, the body of the ammunition truck itself began blocking the firing solution. 150 feet. The AI target recognition system acquired the rear cargo section of the ammunition truck. The lock was not clean. Smoke, dust, and electromagnetic noise were all degrading the image, but it was sufficient to hold directional reference. A 30mm round detonated 10 meters to the left. The shock wave pushed the FPV off the attack axis by 3 degrees. The operator corrected. Not too much. Overcorrection at this speed and altitude would roll the aircraft into the bridge deck. Not too little. 3 degrees of lateral drift at 80 feet would shift the impact point outside the cargo bed. 80 feet. Battery at 11 volts. Thrust at 30%. The aircraft was no longer flying in the precise sense. It was sustaining forward momentum through 4 motors that were drawing more current than the battery could cleanly supply. In an electromagnetic environment that was still partially interfering with the control signal, while a BTR-80A's machine gun crew worked to bring their barrel low enough to reach it, they could not get the barrel low enough. The FPV was 1 meter above the bridge deck, moving at 65 kilometers per hour along the center line of the convoy's approach lane. The BTR-80A's firing depression limit left the final 30 feet of approach outside its effective engagement zone. 30 feet, 10. Impact at 04:39 local time. The FPV's warhead struck the rear cargo section of the ammunition truck at the point where it was crossing the structurally weakest section of the Armyansk bridge deck, a section that had already been compromised by earlier Ukrainian strikes. The initial detonation tore open the cargo bed. The secondary detonations began within 2 seconds as the ammunition stored under the tarpaulin was initiated in sequence. A fireball 18 meters high erupted from the center of the bridge. The shock wave threw metal fragments, sections of bridge railing, and portions of the truck's chassis across a radius of several hundred meters. The vehicle immediately behind the ammunition truck had no time to brake. It drove into the burning wreck and added its own fuel load to the fire. The bridge deck, already weakened at the impact point, fractured under the combined explosive pressure of the initial strike and the secondary detonations. One primary girder deflected downward. The road surface above it collapsed, pulling the burning ammunition truck and adjacent debris into the gap. The convoy behind had nowhere to go. Forward was blocked by burning wreckage and structural collapse. Reverse was blocked by the vehicles that had been following too closely to stop in time. The armored escorts could not maneuver off the bridge. The guardrail sections that still stood prevented lateral movement, and the ones that didn't were over open water. Within 2 minutes of impact, approximately 50 Russian military vehicles, fuel carriers, ammunition transports, logistics trucks, armored escorts, were immobilized on or immediately adjacent to the bridge crossing, unable to advance, unable to reverse, and unable to disperse into defensive positions. The fires from the initial strike and the secondary detonations spread laterally along the convoy as fuel loads ignited from radiant heat. Above the scene, the Leleka 100 continued its orbit at altitude, recording the smoke column that rose from the bridge deck, visible for kilometers across the flat terrain of the northern Crimean isthmus. What the Armyansk operation accomplished was not reducible to the vehicle count or the bridge damage alone. In the context of the broader Ukrainian campaign to isolate Crimea through sequential infrastructure strikes, the Armyansk bridge had been functioning as the fallback option, the route Russian logistics operators shifted to after the Chonhar crossing. Sustained damage in the strikes of June 6 through 9. Ukraine had anticipated exactly that shift. The strike planning against Armyansk had been prepared before Russian convoys began routing through it. When the decision was made to move the convoy, Ukraine was already positioned to respond within 6 hours. That 6-hour window, from intelligence confirmation to strike execution, is itself a statement about the operational tempo Ukraine has achieved in this campaign. It is only possible because the reconnaissance assets, the control infrastructure, and the strike platforms were already in position, and the mission planning had already been completed, against a big contingency that Ukraine's planners had predicted with enough confidence to prepare for in advance. The Armyansk bridge had now joined the Chonhar crossing on the list of Crimean land connections that Russian logistics planners could no longer treat as reliable. With both primary and secondary routes compromised, the options for moving military supplies overland into the peninsula had narrowed to routes that Ukraine was already monitoring and preparing to address. Every vehicle that burned on the Armyansk bridge deck was a vehicle that would not deliver its load to Russian frontline units in Zaporizhia or Kherson Oblast. Every ton of ammunition that detonated in the secondary explosions was tonnage that had already been counted in Russian logistics planning as available for frontline operations that week. The peninsula's supply situation, already under severe pressure from the sustained campaign against the R-280 highway and the Kerch Bridge's reduced capacity, tightened again. The Leleka 100's operator reduced altitude slightly and adjusted the camera angle to capture the full extent of the damage along the bridge crossing. The record would be used for battle damage assessment and for planning the next operation. Somewhere on the mainland, Russian logistics commanders were already working through the same map that Ukraine had been working through for weeks, looking for the next available route, the next usable crossing, the next corridor that might carry the supply flow the peninsula required. Ukraine's planners had already looked at that map. Which Russian supply route into Crimea do you think becomes the next target? Leave your answer in the comments. The operational logic of this campaign makes the answer less unpredictable than it might appear. Stay with this channel. The situation across the Crimean corridor is moving faster than most analysis is capturing. And what comes next in this campaign connects directly to everything covered here.